Good afternoon, everyone. Thank you for taking this time out of your busy day to join us here on this webinar. My name is Brian Barg from Stinson ITS, and with me here is Melissa Cupovic from Miovision. Today, we will be walking through how solutions like Miovision's TrafficLink allow agencies to take a data-driven approach towards improving roadway safety. Now, there is a chat section on the sidebar for you to ask questions that we can address at the end of our presentation. And with that, I'll hand it off to Melissa.
Good afternoon, everyone. We'll start off by talking through some safety statistics. The City of Toronto has 149 red light running cameras, and last year, the city issued 90,000 red light running tickets. We know that in the United States, more than 2 people die daily as a result of red light running. A quarter of traffic fatalities at signalized intersections are caused by red light runners. And we know that 93% of drivers surveyed say it's unacceptable to run a red light, but 43% report having done so in the past 30 days.
Canada is among only 7 industrialized nations where pedestrian deaths are on the increase. The majority of these deaths are older adults or seniors. We are an aging society, and this change in demographic requires a change in timing and infrastructure to ensure the safety of our vulnerable road users. But where do cities start?
Well, Brian, they start with data, whether it's data for the purpose of traffic signal retiming or data to be used to inform urban planning decisions or to understand how to unlock additional capacity. Miovision TrafficLink helps agencies improve the safety and efficiency of their traffic network.
TrafficLink is an ITS solution with several software applications enabled through hardware permanently installed at the intersection. Today, the focus will be on our safety analytics module.
The problem with safety data today is that it is reactive in nature. It is based off of crash data, citizen complaints, or media. One of the most common data points used in safety projects is crash data. While crash data is important, the inherent challenge with it is that it's reactive in nature. You're reliant on a collision taking place, people getting injured or dying, to have a data point to move forward from. Crash data also takes a long time to aggregate before any meaningful analysis can be conducted. The data is only as good as the people filling out crash data reports, and they lack both situational and behavioral context from the crash. When we consider citizen complaints, as is the case with signal retiming projects, there's really no way to verify what your citizens are telling you. Current methods can be costly and don't provide the full picture. Again, with crash data, you're only getting past information without any additional context. On the other end of the spectrum, you can solicit the help of an engineering firm for a safety audit, but they usually run $10,000 to $15,000 an intersection, and the analysis typically entails only analysis of crash data, some manual observation, and depending on the intersection, geometric measurements. For most projects in the public sector, justifying spend and quantifying the impact is crucial to not only gaining the support of your citizens, but also when it comes to securing funding. Time and time again, we see agencies who are able to conduct before-after analysis are at the forefront of getting buy-in from key stakeholders in securing funding.
Intersections are planned points of conflict by design. The majority of these intersections we see on the road are undisturbed, and a small sliver result in crashes and potential fatalities. The area of interest is what happens in between, where near misses occur. For every accident, there's hundreds of near misses. One of the reasons you have a near miss is due to driver non-compliance of road users measured through things like red light running or jaywalking. So we're able to provide these surrogate safety metrics. You essentially have leading indicators into high-risk intersections throughout your network. And that's what TrafficLink safety analytics are all about.
We like to say that good decisions require good data. Taking a data-driven approach towards roadway safety allows traffic teams to proactively investigate countermeasures by providing insight into both the frequency and severity of driver and pedestrian noncompliance. TrafficLink safety analytics are proactive because we're providing 24/7, 365 data collection and metrics that can point to potential near misses, not collisions. From a prioritization perspective, you can use this to support your network screens and address the intersections that are posing the highest risks to citizens' safety first. Once you deploy your countermeasures, evaluating the effectiveness is crucial, which can be done with our before-after analysis to see whether the countermeasure is having the intended impact. And lastly, video. Having that rich medium to provide the situational and behavioral context into your analysis to actually go back and see what was happening at the intersection from the web portal gives you an additional layer of data and insight into causality that you otherwise would not have.
Now, safety analytics requires full stack hardware, and that comprises of the SmartLink, which provides remote access to everything in your cabinet using secure wireless communication, provides a travel time probe and is a data aggregator. The SmartSense, which is edge computing device that runs our computer vision algorithms used for detection and continuous counts. And the 360 Smart View camera is a 4K fisheye camera mounted at the intersection that works in tandem with the SmartSense for detection and counts. And lastly, there's the TrafficLink portal. This software suite for traffic operations is a full data API to integrate to all your systems. The reason safety analytics require our full stack hardware is because we're relying on unique functionality of each component to generate data. The SmartLink is pulling high resolution signal phasing data, which is combined with the turning movement counts from the SmartSense and the Smart View.
So here you have a screenshot of all of the metrics available in our platform. Corridor congestion scans allow you to visualize travel time and speed performance metrics over the length of a corridor. Travel time provides the amount of time it takes to traverse a segment of road between intersections over days, weeks, or months. Approach volumes are upstream detectors to count vehicles arriving at an intersection for each approach. Arrivals on red characterize vehicle arrivals by the interval or the corresponding traffic signal. Green allocation illustrates the distribution of green time allocated to all phases over a 24-hour period. Occupancy ratio uses stop bar detection. Occupancy ratios help identify movements that have unserved demand on a cycle-by-cycle basis. Pedestrian compliance displays pedestrian crossings on flashing don't walk and don't walk phases. Pedestrian delay displays the occurrence and wait time of pedestrian actuation throughout the day. Phase interval displays cycle by cycle, red, green, yellow durations over a 24-hour period. Our Purdue coordination diagrams visualize the relationship between individual vehicle arrivals and signal phasing. Our red light runner report illustrates the passage of vehicles through the intersection during the yellow and red phase. Simple delay displays the average time between stop bar detector actuation during red and when the phase turns green. Split failures visualize stop bar green occupancy versus the first 5 seconds of red occupancy to identify split failures. Split trends characterize values from the split failure chart into 5 groups over days, weeks, or months. And finally, turning movement counts provide classification and pedestrian volumes in our data link platform.
Now, Miovision TrafficLink provides multimodal video detection and continuous, reliable, accurate traffic data collection for operators, engineering, and planning teams, including turning movement counts, volumes, and classification. Classifications include light vehicles, buses, heavy vehicles, bicycles, and pedestrians.
As we mentioned earlier, a quarter of traffic fatalities at signalized intersections are caused by vehicles running a red light. So the first metric we deployed is red light running. We're using our turning movement counts, specifically once a vehicle hits the mid-block of the intersection, and matching that with the corresponding signal phase to generate this chart. Each dot represents a vehicle. The dotted line represents the hourly red light running count. We wanted to draw a distinction between systematic red light runners and non-compliant red light runners so that you can see there's a triangle that represents hits over 20 seconds. Those are road users who blew past the light well after the yellow phase had ended. In TrafficLink, you can actually hover over the dots to get a timestamp to see how severe the red light run was, and use video recall to pull the footage of the red light runner. Post-top bar detection is a common way of getting this data. The reason we opted for our TMCs is twofold. From a configuration perspective, it makes your life easier. If you're already using our TMCs, it's ready to go. There's no additional detection zones that need to be drawn in. We also found that accuracy is better with TMCs, especially when it comes to multi-lane movements. For example, right turns on red are permissible movements in many areas. Using detection, this would go down as a red light runner, which can skew data.
The second metric available is pedestrian compliance. It's similar to the red light running chart, except it's telling you when pedestrians are crossing the crosswalk during a flashing don't walk or a don't walk phase. Similar to the red light running chart, this combines the turning movement counts, specifically once the pedestrian hits the middle of the crosswalk, and matches it with the corresponding pedestrian phase. Reading the chart is similar to the red light running chart above. Miovision intentionally designed them to look the same, but each dot represents a pedestrian. The dotted line represents the hourly pedestrian compliance count, and you can hover over the dots to get timestamps. Now, right off the bat, the one thing you'll notice is that pedestrians tend to be more non-compliant than our drivers. We've seen this all across our data sets, and I'm sure you can relate. Pedestrians are more likely to just dart across the crosswalk if there's a break in traffic.
These are new metrics, so let's take a look at a potential use case of this data and how it can be used to make informed countermeasures. Here are some characteristics of this particular intersection. It is a busy, high-volume intersection, and we have vehicles, pedestrians, bikes, and an LRT line. Looking at the pedestrian compliance chart, we can see that there are high volumes of non-compliance at this intersection, seemingly at random. Given the high volume nature of the intersection, it's worth investigating further.
Now, if we pull up a pedestrian delay chart, the reason behind this non-compliance becomes a little more clear, and this is something we've noticed by looking through our data. The longer a pedestrian has to wait at a crosswalk, the less compliant they will be. In some cases here, you can see that pedestrians are having to wait 4 to 5 minutes. Okay, so that explains the non-compliance, but to make this conundrum a little more confusing, the pedestrian push buttons are working perfectly. So what's the problem?
Well, Brian, remember that we mentioned this is near the LRT line? Whenever it would come by, it would receive a preempt and erase the pedestrian calls that were being made to the controller, which means unbeknownst to the pedestrian, it was as if they hadn't pushed the button. Another interesting trend we've been seeing with the pedestrian compliance chart is that you can almost infer the transit schedule. So to crack this code, what we were seeing was that pedestrians were forced to wait a long time to cross the street, and many of them were being non-compliant to catch the public transit. So now, from a countermeasure deployment perspective, it could be a combination of education and engineering-driven countermeasures, signage for pedestrians, collaboration with the transit team, or even shorter cycle lengths.
Now, when it comes to pedestrian compliance countermeasures, the ideal solution maximizes pedestrian compliance with the pedestrian signal and crosswalk. In cases where there are high volumes of non-compliance, agencies can look at a number of countermeasures that help improve visibility. increase the likelihood of compliance, or eliminate the need to comply altogether. TrafficLink data provides or plays a crucial role in helping agencies identify where and which countermeasures are needed and would be most effective. It enables agencies to demonstrate the impact of countermeasures once they have been deployed. And that is our very short, impactful presentation. We like to make it short and sweet, but just off the bat, we've covered a few things. I'm just wondering here and looking in the chat if there are any questions.
And with that, we'd also love to hear your stories, and if you have any cases in particular that you found really interesting within your own traffic network from a non-compliance or a red light running standpoint.
All right. I don't see anything here. So I would say that concludes the end of our presentation. What I also would say is please join us for our next webinar, which is the NavTech Radar, paving the way for safer, smarter highways in Canada. And that date is October the 7th, 2020. And Michael McGuire, who is Stinson ITS's manager and solution architect, and Phil Avery, who is the managing director of NavTech, and Ajay, who's Stinson's ITS Director of Technical Sales, will discuss this. So thank you very much for joining, and we will talk to you.
Brian,
yes.
It looks like we do have some questions that came in.
Sorry, yes. What is the accuracy of predicting traffic classification? Is that the one that you're seeing here?
Yes. So would you like to take that on, or?
No, go right ahead. I'm just sorry. I'm figuring out the sidebar myself.
Yeah. So when it comes to predicting vehicular traffic, we are looking at anywhere between 90 to 100%. We're also very good at classifying pedestrians, and we're within that range in certain cities around North America. When it comes to bikes, we're currently retraining our AI. So one of the benefits of our artificial intelligence is actually that our system will assign a reliability score to any determination that it makes. So whether that be detection or classification. If it is below a certain threshold, our engineering and computer vision team manually will review that video to ensure that the AI had made the right call. If in fact they determine that it did not make the right call, they take all of that video and all of the imagery from that particular case and they feed it back into our machine learning algorithms to retrain our AI and to ensure that the next time the AI sees that particular object in those conditions, it makes the right call. And right now, we're actually in the process of retraining bikes to get them to the accuracy level where we have that we have on vehicles and pedestrians.
All right, and another question that came in, actually now the questions are coming in here. Can the PED compliance report also show how many PEDs cross on the walk, as well as give a full picture of the PED crossing activity? I'll read out the questions and you can answer them.
Yeah, so we do have pedestrian counting, which would give you pedestrian counts. I'm sorry, I'm just looking at the second part of that, as well as to give a full picture of the PED crossing activity. Yeah, absolutely. So you have pedestrian counts, so you would have a thorough understanding of anything that's going on within that particular crosswalk. How does the system handle data privacy of drivers and pedestrians? So on that front, we're not collecting any personal information. And this was particularly important for us because we actually operate heavily in the United States as well. And in a lot of cases, many of the states have outlawed red light running cameras. So in order to ensure compliance, we do not collect any personal identifiers. All we do is count the vehicles that are behaving in this manner. So when it comes to privacy of drivers and pedestrians, there are no personal identifiers. Our system is also, while we record in 4K, all of the video that is processed and streamed is in a much reduced quality. So you cannot see, anybody's face, for example. You cannot see the license plates on a vehicle. So from a privacy standpoint, we do protect the privacy of road users and do not collect any personal identifiers.
All right, and the next question is, does the system provide vehicle demand and signal green phase provided, i.e. demand vehicle and supply green time analysis?
Yes, we do. We have several charts that speak to this. And what we can do is we can probably send you some additional information. We have your contact information. So I will definitely send you a few screenshots and maybe descriptions of the charts that we have available that would speak to this.
All right, that looks like pretty much all of the questions that we have here. Again, thank you very much for your time. Our contact.
Sorry, there's another one, Byron, that just came in. While
Okay.
not recording individual details, can you track a vehicle or other activity from one point to another, or is data recorded just for a single point but not comparable between points other than in total volume? Okay, so we do track vehicles through the intersection. So we track the trajectory. And we also, there is a travel time probe built in. So it will track, based on MAC addresses, it will track the occupants of a vehicle, for example, through a corridor, which allows us to record on travel time. But all of that is parsed, and it's completely, like, none of the MAC addresses are collected. So from a privacy standpoint, we're not collecting any of that information. And then from data being recorded, it is actually recorded from the time that the system is initially installed. So a lot of the information we collect, like counts, all of the ATSPMs would be made available to you for the entire duration of you having that equipment deployed. But recordings, like actual video recordings, are only stored on our device for 7 days. And once they're recalled by somebody in your agency, they can be stored on our system indefinitely. So the recording is a little bit different from the counts data and the advanced traffic signal performance measures, which we store indefinitely. The video itself is only stored on the device for 7 days and needs to be recalled within that time period to be stored indefinitely within our portal.
And there's another question here I can answer, which is your system capable of counting pedestrians at a transit LRT station or at a platform? The way the counting works is that we're actually drawing a zone in the crosswalks of the intersection, and pedestrians that are going through that would then put in the count. So just kind of randomly grabbing a head count there, that wouldn't, it wouldn't be used for that type of counting.
Yeah, we have done a few things where we've created separate zones and have counted, pedestrians within those zones. So as long as that was within our view, it's something that we could do on the back end. But displaying that information in our chart, for example, would not be possible. It's something that we would have to make available to you separately.
I don't want to say it. I think that's it. Okay, we'll call it there then. So thank you everybody for joining us, and we will get you on our next webinar.
Thank you everyone for your time. Appreciate it. Take care.